Alright guys, clearly I'm not in class today, so I wanted to make sure you guys had some notes and that the learning continued. And so I'm going to go ahead and go over these notes with you. We're working on difference of two squares today, sum of two squares, and factoring by grouping. Okay. The first topic on the top here is GCF factoring, and this is something that we've already done, but you guys struggled with that yesterday, so we're going to kind of go over this again. I'm going to do the first two, and then you can do the next two on your own. Advantage of having a video is if you don't get it and you got questions, you can always pause, rewind, play it again, and have it forever, so you can always go back and kind of check it out. Hopefully you can hear me because, again, I'm riding in a car right now. All right, let's move along. So first thing is we're looking for a GCF because that's what we always do when we're factoring. In this case, you want to see if, again, like I always say, if the smaller number goes into the larger number, and that smaller number is 4, and it does, and so 4 is the GCF. All right, then, oh wait. Notice they both also have a variable. And so you have an x squared and an x. And so remember, the smallest variable always wins because you can take one x out of there. All right. And if you have two terms out here, you know you're going to have two terms inside your parentheses. How do you determine what those two terms are? You divide by the GCF. So divide by 4x. Divided by 4x here. 4 divided by 4 is 1. We don't need that because it's just a 1 in front of the x. That's what's always understood to be there. And then for this here, 2 minus 1 is 1. And so we have just an x. Sorry about the GPS there. Continuing along, you got a negative 16 divided by a 4, that becomes a negative 4, and then you have a 1 minus 1 there. Those x's cancel out, and that leaves you with what you currently see here, and that is as far as you can go. Always want to look in the parentheses here and see if you can factor out any further. In this case, you cannot. Okay. If you have questions on that, go back, watch it again, right? GPS talking again. As you can see, I'm almost into Orlando. All right. Next, again, you want to see if the smaller number, because we're looking for the GCF, can go into the larger number. In this case, 3 can go into 27. And then we also have an x to the 5th and an x to the 2nd. Remember, when you have the same variable on the terms, the smallest exponent wins, and that is part of your GCF. So we have 3. Oops. We have our 3x squared. How do we figure out what's on the inside? We know there should be two terms, and we're going to divide by our GCF. Again, you're going to divide by your GCF. Guys, you're going to be hearing that GPS, so just bear with it. So 3 divided by 3 is 1. No, we don't have to put that. Or if you wanted to, feel free. There's 1. Then you have a 5 minus 2. I'll use my pointer. 5 minus 2. For those of you that don't understand what's going on there, that leaves us with 3. So x to the 3rd. And then you have 27 divided by 3. That is 9. Positive 9. And then 2 minus 2, that cancels out. that leaves us factored as far down as we can go. Again, we don't need, oh, go back. Let's undo that. I was going to try to erase that one, but the eraser's too big. All right. But just remember, 1 is understood, so technically that 1 does not have to be there. And so that is our answer. So the next 2, y'all go ahead and do those 2 by yourself. You can pause, and then when you're done, go ahead and just resume from there, and I'll have the answers up for you. Okay, and so we're back. Hopefully you have paused it, and you did it, and you got the correct answers down here. You should have found a GCF. That GCF would have been 4. Notice these ones had variables on them because each term had a variable on it. This one, all the terms did not have an X on it, so the most you could have pulled out was a 4. You needed 3 terms in there. You would have divided all those by 4, and this was what you would have gotten, and you would not have been able to factor down any further there. Same thing here, except this one does have a variable on both of them, and so you have a variable outside here, and the smaller exponent came out. And I left you with this on the inside, and that is GCF factoring for you. All right, so guys, kind of pause it here, and when you pause it, hopefully you didn't pause it right there on my pause, but you want to pause so you have enough time to write down these notes right in here, because we're about to go into the difference of 2 squares, and you want to look for subtraction. You want to look for a binomial, which is 2 terms. So basically, if you go up here and look, this is a binomial. So 1 term, 2 terms, and then there's a subtraction in the middle. So subtraction in the middle with 2 terms, 1, 2. You're also looking for perfect squares. That's 1, 4, 9, 16, 25, 36, and so on. So pretty much if you want to create a list of perfect squares, just put 1 squared in the calculator, 2 squared in the calculator, 3 squared, 4 squared, and all the way up, so you can get yourself like a list of perfect squares. And you can kind of jot this down right here as well, and I'll explain that when I get back. But this is really just difference of 2 squares. Don't let this confuse you, because you'll see what we'll do here in the next clip. So pause here and get all the notes. So let's get into some of the practice problems here. And so, guys, this is very, very easy, and you should not overthink this. So looking at number 5 here, you have 2 terms, and in the middle you have a subtraction sign. So you got to look at these 2 numbers here and see, or 2 terms, and see if they are perfect squares. Okay, so this right here is x squared. That tells you that it is a perfect square. Okay, this is 16. If you made a list of your perfect squares, 16 is a perfect square. Okay, so here's the process. You look at this and you want to get that 2 off of there. The opposite of a square is a square root. So guys, it's really this simple. All you do is take the square root of this. Oh, bumpy car ride here. Take the square root of that, and what that does is it cancels that, and then you take the square root of that and see what you get. So punch it in your calculator and see what you get. Once you punch it in there, you'll have x plus 4, because the square root of 16 is 4. And once you have that right there, that factor, all you do is write the exact same thing with the opposite sign. X minus 4. Now, if you were to multiply that back out to check your answer, you would end up with x squared minus 16. Okay, let's look at number 6. So here, again, first thing you do when you see 2 terms, on number 6, you see 2 terms. You want to look for a GCF. Is there a GCF? So know GCF? Are they perfect squares? Yes. If you don't know, just try to take the square root of it, right? And if it comes out as a whole number, not a decimal or not a radical, then you know it's a perfect square. You can take the square root of 36 and you can take the square root of 121. And so let's go ahead and do that. Square root of that, square root of that. And so the square root of 36 is, this car is bumpy, guys. Square root of 36 is 6. And the square root of x squared, remember all it does is cancel that 2, so you have an x. Square root of 121 is 11. So we have 6x plus 11. And what do we have next? Of course, the opposite sign, 6x minus 11. If you want to check your answers, just go ahead and multiply that all back out. Let's move on to number 7. First, look for a GCF. Is there a GCF between 25 and 16? No, there's not. But you do have two terms separated by a subtraction sign. I'm thinking, once again, difference of two squares. So, can you take the square root of 25? Yes, you can. Can you take the square root of 16? Yes, you can. So let's do that. Square root here, square root there. Square root of 25 is 5. Square root of x squared is x. Square root of 16 is 4. 5x plus 4. 5x minus 4. Y'all should be pretty much getting this at this point. Let's do number 8 before I let you try the practice by yourselves. So once again, two terms separated by a subtraction sign. That's a square. That's a square. So, can you take the square root of 4? Yes. Can you take the square root of 81? Yes. So, let's work this as difference of two squares. Square root of here. Square root of 4 is 2. Square root of x squared is x. Square root of... sorry, car, it's bumpy again. Square root of 81 is 9, and then the square root of y squared, remember guys, all it does is cancel those squares, is y. So I have 2x plus 9. What do we have next? 2x minus 9y. Alright, you're going to want to get some practice in again, so go ahead and pause the video here. This should be pretty quick for you guys. Alright, so take about 7 to 10 minutes or so, if that, not even. Like 5 to 7 minutes and knock those few problems out right there, and then I'll come back with the answer. So go ahead and pause now. Oh, phone's ringing. Okay, so guys, I'm not going to work through 9 through whatever here under the difference of two squares. There's the key there with you. So if you need to check your answers, check with Mrs. Mitchell, and she'll help you check your answers on that. So let's move along to the next part. All right, so look on your notes where it says sum of square notes, and jot this down right here. Okay, so pause it real quick and hang on, GPS. Okay, so pause the video, jot that down, and we'll come back and we'll show you how to do the sum of two squares. Okay. Alright, so now we're doing the sum of two squares. Guys, this is exactly like the difference of two squares, except now you got to bring in the imaginary numbers. This GPS is killing me. Hang on. Okay, so the only difference between the difference of two squares and the sum of two squares is the sign in between the terms changes from a negative or a minus sign to an addition sign. Okay, and so you see that, now you know you have to have an I in your factors. Okay, so you look at it, again, look for a GCF. If there's a GCF, take it out. In this case, there's not. And so we're doing the exact same thing. So we want to take the square root of this and the square root of this. And so we have x, and then we have the square root of 64. Then you have plus 8. And guys, so here's the only difference. Since this is addition, okay, only thing you're doing after you take the square root of 64 is you're going to put an I right there after the second term. You're going to close that, and then obviously you're changing this sign just like you did before, x minus 8i. Because if you remember when we went over complex numbers, if you were to multiply this all the way back out, you'd get an x, or you'd get an I squared. That would change to a -1, blah, 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 blah. And then you would eventually get back to this right here. And so the only way to get back to that is to have an I in there. Let's look at the next one. So you have x squared plus 9 on number 16 here. Is there GCF? No. Are those perfect squares? Yes. Is it a sum of two squares? Yes, because there's addition there in between them. So take the square root, take the square root, that's an x, plus square root of 9, put in your calculator to find out, it's 3. And it's an addition sign there, so we know an I is going there. That's an x plus 3i, x minus 3i. Again, I'm going fast, but guys, you have the benefit to be able to pause, rewind, and play this back anytime you want. So, no excuses. Going down to number 17. 17 is x squared plus y squared, both perfect squares. Addition in the middle, so we have a sum of two squares. Take the square root of that, take the square root of that. That leaves me with an x plus y with an I, because there's an addition in the middle. No difference between having a number there on that second term and having a letter. So x minus y I. And then the last one here that I'm going to go over with you guys is number 18. Again, is there a GCF? So no, there's no GCF. Again, you got two terms, both perfect squares with addition in the middle. That means we'll have a sum of two squares. Once again, of course, because that's what we're working on. Square root, square root. Square root of 9 is 3. Square root of x squared is x. Square root of 121 is 11. And since there's a sum, we have an I there. So 3x plus 11i and 3x minus 11i. All right, again, practice below, practice below. If you need help answering those, go back, watch me work through those examples again, and try your best.
Thank you.
So you go ahead and pause there. I'm going to give you a chance to pause, work on those. Again, the key is there for you if you want to compare your answers as you go. All right, and then moving along, guys, I can't remember if these grouping notes that I have right here are on your sheet or not. Yours might just be blank. So if it is blank, go ahead and fill these notes in right here, all that good stuff. If it's, so you'd have to pause the video to do that, clearly. If it's not blank and it is filled in, don't pause the video and let's get it. So grouping, you'll notice when you see four terms, you're going to think grouping. So again, you see one term separated by subtraction, separated by subtraction, separated by addition. That leaves you with 4 terms. When you see that, you're going to want to group them together with parentheses. 2 terms in each set of parentheses. So let's do that. Take the sign that's in front of the term, and so in this case, let me highlight that. That minus sign has to go in the set of parentheses as a negative. Okay. Now, when you're grouping, you should be looking again for a GCF. So we're going to look first at this set of parentheses right here. Okay, and so what can you pull out of there as a GCF? That's a 1, that's a 2, so we know we're not going to pull out a 1 as a GCF, and so now we're looking at our letters here. Smallest exponent wins, and so what do we pull out? We pull out the x squared. How do we get what goes inside the parentheses? Is you're going to divide by x squared, divide by x squared. 3 minus 2 is x, and then 2 divided by the invisible one that's in front of that x squared below it is a minus 1, but we're not going to put that. Actually, here we are. Or no, actually, I'm sorry. Negative 2 divided by 1 is negative 2. And then 2 minus 2, these will cancel out, so your x is gone. Okay, so key thing here, guys, if you're factoring by grouping correctly, this next set of parentheses should equal out to the exact same thing in there. So I'm just going to go ahead and write it in advance. So when you pull out your GCF, it should all match up. And so you look here, you have a negative 9 and an 18. Can 9 go into 18? It sure can. And so we're going to pull out our GCF of negative, probably need my pen here, of negative 9. Okay. And now we're going to see if that multiplies back out to check it. So negative 9 times x, that is negative 9x, and then a negative 9 times a negative 2 is a positive 18, because a negative times a negative is a positive. And if you don't understand that, we can go back. Let's erase that. So you can just always say, look, same thing you did here. Is there a GCF there? You try to take your smaller number and divide it into your larger number. Sorry, my brain is like shutting down because it's so freaking late out here. And it does. And so you can pull out your 9. And that's likely what you guys would do, but you want to pull out the negative with it so the parentheses match up. Okay, so you can pull out a negative 9. A negative 9 can go into 18. And so to figure it out, you go negative 9 dividing by the GCF, negative 9. Negative 9 divided by negative 9 is 1, and that just leaves your 1x in here. And then an 18 divided by negative 9 is a minus 2. So here's the crucial part. You look down here, this set of parentheses does match this. So you know stuff is working out the way that it should work out. Now follow closely. Whatever you have outside the parentheses, again, whatever you have outside the parentheses, you put that in a set of parentheses by itself. So x squared and a minus 9. Drop that in there. And then you take and you group this x2 to, actually you don't group, you just, since that's the same, you just bring it down as 1. Okay, so 1 by itself. Okay, so are we done? No, we're not done, because you got to look inside here and see if you can factor any further. You look, this one you cannot. you look here, and this is a perfect square. That's a perfect square, and it's separated by a subtraction sign, which means we have a difference of 2 squared. So, a difference of 2 squares, rather. So now, you got to take the square root of that, and the square root of that, and that's going to leave you with x plus 3, x minus 3, and then you take your remaining factor and you bring that along for the ride. X minus 2. Now you're done. Seems like a lot, right? It is kind of a lot, not gonna lie to you. But we gotta keep it moving. Alright, so again, last one I'm gonna do for you, and then I'm gonna leave the last 2 examples for you. Again, 4 terms, we're gonna factor by grouping. So that, remember to take the positive sign in there with 3x. We're going to look for a GCF here. Check to see if the smaller number goes into a larger number. It does. And so that is your GCF. And then these both have variables. So this one with the smaller exponent wins. And so you have a 2 and an x squared. So 2x squared is your GCF. You should have 2 terms inside. How do you figure that out? You divide by 2x squared. 2 divided by 2 is 1. And then that 3 minus the 2 is x. Do the same thing here. Divide by 2x. Oh, bumpy car ride. 2x squared. Let me get myself some more space here. Let's redo that. Again, GCF is 2x squared divided by 2x squared divided by 2x squared. 2 divided by 2 is 1. 3 minus 2 is x. Negative 8 divided by 2 is negative 4. And then the 2 minus 2, those x's cancel out. There you have it. Alright, next one, you're looking at 3x minus 12. And so you want to look for the GCF there. Does 3 go into 12? Yes, it does. So we know our GCF is going to be 3. Then we want to divide by that to figure out what goes inside. 3 divided by 3 is 1x. Or is 1, and then you bring your x down. And then negative 12 divided by 3 is minus 4. And look what we have again. Parentheses match up. That's how you know you're on the right track. Now you take these factors outside the parentheses, group them together as 1, 2x squared, and a positive 3. And then you take the one that matched and you keep it together as 1. Then, last step, check and see if you can factor any further. And you cannot. That is not a sum of 2 squares there. That is not a sum of 2 squares because 3 is not a perfect square. So, that is your answer. Alright, you're on your own on the last 2. There is a key, and so you can match that up on the key. Play this back. Watch it again. Miss Mitchell, feel free to give them the YouTube link that I send to you if they need to go home and look at it over the weekend. Enjoy the pep rally. Enjoy your weekend. See you on Tuesday.